So, a very good morning to all, and welcome to my class. Today, we are going to discuss thermochemistry part 2. Right. So far, we already covered the part 1, in which we covered all the important concept and the important topics. Right. So, in this class, we are going to do some numerical, that is the numerical that were come in your previous examination, right? So in today class we are going to do some numerical as well as some remaining concept, right? So this is for all today. We are going to do some concept which is left behind, and some important topics, and try to cover all the PYQ related to this chapter. Okay, so let's start with the today's session. I hope my screen is visible to you and my voice is also audible for all of you. Right. So let's study what is standard enthalpy of reaction. So basically, we already studied the enthalpy of the reaction. What is this? That is the heat content of the system at a constant pressure is known as enthalpy. On the similar basis, if someone asks what is standard enthalpy of a reaction, it means the enthalpy at 1 bar of pressure and 298 Kelvin, a substance is said to be in standard state, right? So basically, in a standard enthalpy of reaction, we have to calculate the enthalpy at the standard condition. What do you mean by the standard condition? Standard condition means when the pressure is 1 bar and the temperature is 298 Kelvin. So this is termed as a standard condition, right? So enthalpy at the standard condition is known as standard enthalpy of a reaction. Similar, hence, when the reaction is carried out at the standard condition, its enthalpy change is called standard enthalpy of the reaction. And the sign of the enthalpy of the reaction get reversed in reversing a chemical equation, right? So if you reverse the chemical equation, then the enthalpy sign is also changes. If it is negative, it will become positive, and if it is positive, it will become negative, and vice versa. Okay. So what are the various factors which affect the enthalpy of the reaction? So there are various factors on which enthalpy depends. The first one is that is the physical state of reactant and product, allotropic form of element involved, chemical composition of reactant and products, amount of reactants, temperature, and the medium of the reaction. So these all are the factors on which the enthalpy, or we say heat at constant pressure, depends. Now, the variation of the enthalpy of a reaction with the temperature is given by the Kirchhoff's equation. So by Kirchhoff's equation, we understand what is the variation of enthalpy in terms of temperature. So what happening when the temperature of the system is increased or decreased? So what is the effect of temperature and enthalpy? Will better understand by the Kirchhoff's equation. So what is this? So according to Kirchhoff's equation, let us consider the two cases so that we understand this thing. So case one, when the Cp is then constant between the two temperature, right? When the specific heat at constant pressure, that is Cp, is constant between the two temperature T1 and T2. So let's say we know that delta H2 minus delta H1 enthalpy is nothing but Cp into delta T, that is specific heat at constant pressure into temperature difference T2 minus T1. And similarly, we know that at a constant volume, we have a internal energy like E2 minus C1 is equal to Cv, T2 minus T1. So from equation 1 and 2, these are known as the Kirchhoff equation. Okay. So delta Cp varies with the temperature. How we'll show that? We'll show that by, we know that delta H is nothing but it is equal to H naught plus Cp into dt, right? Where H naught refers to the enthalpy change at absolutely 0 Kelvin, right? When the temperature is absolutely 0. So delta H is equal to H delta H naught plus alpha T plus B T square upon 2 plus gamma T Q upon Q. So this equation, that is equation third and fourth, are the another form of the Kirchhoff's equation, as we can show that how the temperature is related to the enthalpy. Okay, so how will you calculate enthalpy for the particular reaction? If some reaction is going on, how will you calculate the enthalpy of the reaction? So basically, calorimeter is the apparatus which is used to measure the heat of the reaction, right? So basically, we use calorimeter. Calorimeter is the basically apparatus that we use to measure the heat of the reaction experimentally. Now, if you know the water equivalent of the calorimeter, that is W, mass, and the specific heat, that is S, of the liquid, and the initial and final temperature of the calorimeter, the heat of the reaction is calculated by using the below formula, right? So we're going to see the formula by which we can calculate the enthalpy of the reaction. So basically for calculation of the enthalpy of the reaction, we use calorimeter. And for calorimeter, what data we require? So basically we require the water equivalent of the calorimeter, W, mass, and the specific heat of the liquid and initial and final temperature of the calorimeter. So if you know this data, then we can put the put this data in the particular formula for calculating the enthalpy of the reaction, and we can calculate by using the calorimeter, right? So which formula we use basically, beta? So this is the formula. Just remember this formula. This one is very, very important. So this is the formula, that is Q is equal to W plus M into S T2 minus T1. So this formula we basically use for the calculation of the enthalpy of the reaction. Yeah, where the capital W is the equivalent weight of water, right? So calorimeter. There the two common types of calorimeter are basically water calorimeter and bomb calorimeter. So calorimeter further classify into the two different types. One is known as a water calorimeter and the next one is known as bomb calorimeter. What is water calorimeter? So basically in the water calorimeter, pressure remains constant, right? That is give the heat at a constant pressure, or we know that enthalpy, because the heat content of the system at constant pressure is itself known as enthalpy, right? So in water calorimeter, pressure remains constant. So the heat obtained here is are at constant pressure, or we say delta H. Now in the bomb calorimeter, the volume remains constant, and we know that the heat at a constant volume is termed as internal energy, right? So we can calculate delta E as W plus M into T2 minus T1 into S upon W1 into M, where capital W is the again equivalent weight of water, small m is the mass, and T2 minus T1 is the temperature difference. W1 we know mass of the substance taken, and capital M is the molar mass, right? So this is the usual meaning of this term. Now, there's a concept-based question related to this, and this question is very simple. If you know the small things, just put the values and you'll get these data, right? So what the question basically asks, beta, in question what you have to calculate. In this question they are asking 0.61 gram of methane is subjected to a combustion at 27 degrees Celsius in the bomb calorimeter system, right? The temperature of the calorimeter system including was found to be rise by 0.5 degree. You have to calculate the heat of combustion of methane, right? You have to calculate the heat of combustion of methane. So in this, just you have to calculate the enthalpy, nothing else, right? So just need to calculate the enthalpy here. So how will you calculate? Can anyone tell me how will you calculate the enthalpy of this reaction by the given values? No, no one. Okay, so let me discuss with you that how will you calculate by using a simple formula. Just we wrote here, right? Just by using this formula only, we can easily calculate the value. So in this, we have to calculate the value of what you have to calculate. Thermal capacity is already given. The temperature of the calorimeter also given. The heat of combustion of methane. So we have to calculate the heat of combustion of methane, right? So nothing but heat of combustion of methane. So let's see how will you calculate this heat of combustion of methane. Okay, right. So basically, first of all, what is given here? Mass is 0.16 gram. So let me write here. The mass is already given. That is mass is 0.16 gram. Let me write. Right. So given data is what? So the given data is mass. Mass is already given. Mass is nothing but 0.16 gram of methane, right? Of CH4. Can you tell me the molar mass of methane? Right? Can anyone tell me the molar mass of methane? What is the molar mass of methane? Yes, molar mass. Yeah, right. So anyone? Molar mass of the methane? That is nothing but 16, right? Because C having mass 12 and 4 hydrogen having a 4, that is 12, right? And the temperature also is given, and the temperature difference, that is delta T. So delta T is nothing but the temperature of the calorimeter system including was found to rise by 0.5 degree, right? 0.5 degree. So total rise in the temperature is nothing but 0.5 degree. So delta T is equal to 0.5 degree. Okay, anything else? The thermal capacity of the calorimeter. So thermal capacity means C is already given. So see the value of C, 17.7 kilojoule per Kelvin, right? Kilojoule per Kelvin. So you have to calculate the heat. So we know that the heat at a constant volume is termed as internal energy, right? The heat supply at a constant volume is known as internal energy. So we know the formula for calculating the internal energy like delta E, right? So this is the formula we use. We already derived this formula, right? Delta E. So delta E is equal to C into delta T into molar mass upon my mass, right? So if you know this value, then you can easily calculate the, because in the bomb calorimeter, V remains constant now. So volume remains constant. So you have to calculate this only. So what is C here? C is nothing but 17 point C. What is T here? Nothing but 0.5. What is molecular mass? 16. And what is mass beta? 0.16. Right. So on solving, you can easily solve 16 to 16 cancel out हो जाएगा. So what you will get here is that is minus 885, right? 885 kilojoule. So out of the four option, which will correct? That is the option number 4. Right. So I hope this is clear to you. How will you calculate the enthalpy, or we say by using the bomb calorimeter. So this is how we can actually calculate. If the question is in a constant pressure, then you have used the then we have to use the formula like this. That is Q is equal to W plus M into S into T2 minus T1. Right. But here in this question, we have to calculate at constant volume. So at constant volume, we use this formula. Now, the next thing is you have to calculate what you have to calculate, beta. You have to before calculation, you must know what is enthalpy of formation. So from now we are going to study some different types of enthalpy, like enthalpy of formation and enthalpy of sublimation, enthalpy of combustion as well, right? So let's see, what do you mean by this term enthalpy of formation? Basically, the enthalpy change when 1 mole of compound is formed from its element in their most stable state of aggregation is called enthalpy of formation, right? So basically, the enthalpy change when the 1 mole of compound is formed from its element in their most stable state of aggregation is called enthalpy of formation. For example, delta HF we can represent as whenever the graphite or carbon is treated with hydrogen in presence of 2H2, it will produce CH4, and here the energy released is equivalent to minus 74.8 kilojoule, right? The above enthalpy change under the standard condition like 180 and 298 Kelvin is called standard heat of formation, and it is denoted by the delta HF norm, right? So this not delta HF not, this not symbol represent the standard state. So basically, what is the enthalpy of formation? As the name suggests, now formation. So whenever the certain amount of this will form, right? So this is known as the enthalpy of formation, right? Basically, when a 1 mole of compound is formed from its element in their most stable state of aggregation is called enthalpy formation, right? Now, enthalpy formation of element at the standard state or in the most stable state by convention is taken as zero. Like enthalpy formation of magnesium, aluminum, NaH2, O2, F2 is taken as 0. So just remember this thing. Now, in this question, given that KOH plus HCl, here the enthalpy is given. Enthalpy is like minus 57.3 kilojoule per mole. H2 plus half O2, H2, and here also the enthalpy is minus 286.2 kilojoule per mole. Now, in case of this, right, in case of half H2, half H2 plus half O2, half H2 combined with the half Ca2 to form HCl. And here also delta H is given, that is minus 164.4 kilojoule per mole. Right. Now K plus half O2 plus half H2 plus aqueous, this will give us KOH. Right. So delta H is nothing but here also given 487. So in this equation, you have to calculate the heat formation of KCl. So what is the heat formation of KCl actually? Right. When the KCl is formed, what is the heat formation of KCl? So from the five equation, total fifth equation, you must know how will you calculate the formation of KCl. KCl is basically formed when the K is treated with the Cl, right? When the 2K is treated with the 2Cl, then the 2KCl will be formed. So you have to, understand the formation of this. Okay. So let's see this. How will you actually calculate? Because these type of questions were generally coming in your examination, so you must know how to calculate such type of reaction, right? So let's see the solution for this. Right? So let's see. Okay, from this equation itself, can you anyone tell me how will you form a KCl? Because in this question, they ask you have to calculate the enthalpy formation of this, right? So can you anyone tell me how will you actually form this, right? So as we see, it is very clearly for from the diagram that is what is the required what is the required equation for us, that is we want K plus Cl2 here to become KCl, 2 KCl, let it be 2 KCl. So when the 2K plus Cl2 react, it will form 2 KCl. So from which two equation will get this? From which equation will get 2 K beta? So from equation number 4 we'll get 2, right? From sorry, K, right? And from equation number 3 we'll get Cl2, right? We'll get Cl2. No issue? Good. So as we can just add this equation, right? So add, right? Add equation. Which one? That is third and fourth. So if we add equation third and fourth, what you will get? We will get like in equation third, what we have? In equation third, we have half H2, right? Plus half Cl2 plus in equation fourth we have K plus half O2, right? Is equal to right hand side. You can also add SCl plus, and here we have KOH, right? KOH. SCl plus KOH. Then the formation is like this is nothing but SCl, right? So here only SCl will be formed, right? Here only SCl will be formed now. Fourth and subtracting equation fifth. No, from these two we get only this. How from which equation we'll get KCl? Right, this is the desired one. Just remember this. This is the desired equation. From which equation we'll get KCl beta? That is equation 5. KCl is in right hand side, right? So from which equation we'll get this? That is from equation number 5. Okay. So just subtract this and subtract equation fifth from we get. So what you will get beta? Basically 1 H2 and half Cl2 and K. So this H2 and O2 will become H2. So on solving, what you will get basically is add equation 3 and 4 and subtract equation 5. So when you do this, add equation 3 and 4 and subtract 5, what you will get basically on solving, you will get like that is nothing but K. Again, I'll write here K plus half Cl2 plus again H2 plus half O2, right? And this will gives us KCl plus SCl plus KOH minus KCl. Equation 5, right? So this is what we get from the equation this, right? From the equation uh, 3, 4, and 5. Okay, so just put the values of here delta H here. So what you will get, what we will get here, we will get like delta H comes out because we know the value of each, right? What is the value of this and this? When the H plus half O2 is treated, we know the value. So if you put the value of delta H, we know delta H comes out to be, just put the value, we'll get delta H comes out to be 670.2 kilojoule per mole. Okay, now add equation 1 to this equation, right? We get this desired equation as a, let me write this equation as equation number 6, right? This act as a equation number 6. Now, what we have to find, our aim is what? So we already discussed our aim is either 2K plus Cl2 is equal to 2K Cl. Then after we can calculate for the KCl, or simply we can say K plus half Cl2. This will also give KCl, right? So this is our desired equation. So add equation one, this equation, right? Add equation one to the seventh equation. So in equation number seventh, just we add this, right? So just add equation one to equation number six and subtract equation two. So we'll get this delta H, right? So delta H is nothing, but this comes out to be minus 670.2 minus 286.2. So we'll get like this minus 441.3 kilojoule per mole, right? So this is how we can get this. Actually, for solving such kind of question, just remember what is your aim. If you know the aim, then you can easily calculate by eliminating the other values. So you can calculate. It is very much simple from the given equation that again, if someone getting confused, we have a no. Just think one important thing. What is aim here? So aim is very much clear. That is, aim is nothing, but we have to calculate K plus half Cl2, which gives us KCl. Now, quick observe very carefully from which equation we get this, right? So from equation fourth we get K, from equation third we get Cl2, and now from KCl what you will do from KCl will get from the equation number fifth, right? And also KCl we get from the equation number one as well, right? This is KCl plus HCl. This will go KCl plus H2, right? So this will get from the equation one as well. So just focus on the aim. So if you just do this requirement, that is add equation 3 and 4, add equation 3 and 4, right? 3 and 4. So if you just add equation 3 and 4 and subtract the equation 5, you'll get the this one, that is 670.2 kilojoule. Now after this, just remove the remaining values. So if you remove the remaining value, you get the answer, right? So this is how you actually solve such type of question. Now, the next thing is you have to calculate the enthalpy of, right? So now in this, now you have to understand what is enthalpy of fusion. What is the enthalpy of fusion all about? Basically, enthalpy change when the 1 mole of solute substance is converted into liquid state at its melting point is called enthalpy of fusion, right? Basically, ionic solid have a high values of enthalpy of fusion as compared to the molecular solid. Clear? The enthalpy, basically, what is enthalpy of fusion? As the name suggests, the enthalpy change when the 1 mole of a solid substance is converted into liquid state at its melting point is called enthalpy of fusion, right? Basically, ionic solid have a high value of enthalpy of fusion as compared to the molecular solid. On the similar basis, if someone asks what is enthalpy of vaporization, what do you understand by this thing? Enthalpy of vaporization. Does the name suggest the amount of heat or energy required to convert it to this when the vapor form is exists, right? So basically, the enthalpy change that accompany vaporization of the 1 mole of a liquid at its boiling point is called the enthalpy of vaporization. Just remember this term, at boiling point. This one is important, right? So enthalpy change that accompanies vaporization of the 1 mole of liquid at its boiling point is called enthalpy of vaporization, right? High value of enthalpy of vaporization show the presence of a strong force of attraction. So if the value of enthalpy of vaporization is high, then it must be the bond between this between the two liquids, or maybe liquids and solids are very, very strong. Now, what is enthalpy of sublimation? Right. So basically, what do you mean by the enthalpy of sublimation? So it is defined as the enthalpy change when 1 mole of solid sublimates. Right. So it is defined as the enthalpy change when the 1 mole of solid sublimates, that is converted directly into gaseous state at a temperature below its melting point. It is represented by delta S, right? So this is known as the enthalpy of sublimation, which is defined as the enthalpy change when the 1 mole of a solid sublime or it's converted directly. Sublimation means what? Which convert directly from solid state to the gaseous state without converting into the liquid state, right? At a temperature below its melting point. It is represented by delta H of sublimation. Now, This one is also very important, and this one is the most common one. That is the enthalpy of combustion, right? So basically, what is enthalpy of combustion is that is the amount of heat evolved or absorbed when a one mole of the substance is completely burned in oxygen or air is called enthalpy of combustion, or we can represent as delta CH, right? For example, when the CH4, that is a hydrocarbon, is treated with 2O2, the formation of CO2 and H2O will take place, and delta C of H here is nothing but 192 kilocalorie. Now, the value of this delta CH is always negative. This is because heat is always evolved during the combustion. So this you must remember, the value of delta CH is always negative. That is, this is because heat is always evolved during combustion. Now, the grading of the food article and the various fuels can be done on the basis of the values of the enthalpy of combustion, right? It means which fuel is good, or we say which wood having high calorific value, like grading like this, they can be done on the basis of enthalpy of combustion only. If the heat of combustion is measured in kilocalorie gram or kilojoule per gram, that is calculated for the 1 gram of substance, it is also called the calorific value, right? If some wood or some fuel having a high calorific value means it produces more energy. In other words, the amount of the heat produced in a calorie or a joule when the 1 gram of substance, food or fuel is completely burned or oxidized is called the calorific value. Mathematically, we can write the calorific value like delta CH upon mass, right? So this is how we can write the calorific value. Here in this table, I am just collecting some different calorific values for the different items, right? For example, wood. So wood having the CV value or a calorific value 7, that is 7 gram in 1 kilogram of the fuel, right? So wood having the 17 calorific value. Similar, if I'm talking about the charcoal, charcoal having charcoal having also better charcoal having 33 calorific value, kerosene having 48 calorific value, methane also having 55, LPG 55, hydrogen having 150 CV value. So hydrogen is having very good amount of calorific value. Milk 3.1, egg 6.7, and similar rice we have a 16.7. Right? Similar, sugar, we have a 17.3, butter 30.4, and ghee 37.6. So this is the calorific value for the different things, right? Ghee having very good calorific value. Now, out of the fuel listed, hydrogen has the highest calorific value. However, it is not used as a domestic or industrial fuel due to some technical problems, like their method of preparation. It is very difficult to prepare hydrogen. Of the various constituents of our food, the fats and carbohydrates serve as the main source of energy. The calorific value of the protein is quite low, right? Now, so this is a very simple question. In this question, they are asking delta H is given, right? Delta H for the reaction is already given, and you just have to calculate the calorific value, right? So how will you calculate this beta? Can anyone? Right? So delta H for the combustion of ethane and ethane are given, right? So delta H of combustion for ethane and ethane are given. Which is the better gas filter? It means which one is the better gas filter means which will produce more heat, which having the more calorific value. Those having those having the good calorific value having obvious having good better gas, right? So which is a better gas for the better gas filter. So let's see what happened actually. Basically calorific value means right, so the calorific value is equal to calorific right? So calorific value, what is calorific value beta? Calorific value is equal to heat produced by 1 gram of fuel. ठीक है. So calorific value is nothing but the heat produced by the 1 gram of fuel. Now it already given that is the enthalpy combustion of C2H6, that is ethane, is nothing but 341.1. And similar, so what is the calorific value is? What is the calorific value, beta? We know that in ethane having C2 30. So we know that they having molecular mass 30. So 30 gram gives us this much of, that is 341.1, right? 341.1. So this is the delta ethane. This is for ethane. So similar, 1 gram is how much is create 341.1 upon 30, which is comes out to be 11.37 kilo calorie per gram, right? 11.37 kilocalorie per gram. Okay. Similar, if I'm talking about the next one, that is ethyne, right? So delta C for ethyne is nothing. Ethyne having formula C2H2. C2H2. So they having formula like they already given minus 3 110. So 1 gram of this required because 14 12 12 24 24 और 2 26 26 that is 26. So minus 310 upon 26. Okay. So here you will calculate this. So it will comes out to be 11.92 kilocalorie per gram. Right. So this will comes out to be this. Okay. This is also minus. This is minus 11.92. This is minus 11.92. And this is minus 11.37. So which one having higher as the value of ethylene? This one, है ना? Because negative na negative whole values with it will be smaller, right? So this is 11.92 kilocalorie, and this will produce 11.37, right? So as the calorific value of which one having more? Calorific value of ethine. Negative sign just represent the energy released. There's nothing more to do. So as the CV value of ethine, that is C2H2, is greater than the calorific value of C2H6. So we can say that ethine used as a gas welder, right? So ethine used as a good gas welder as compared to the others. I hope this is clear to you. Anyone having any kind of doubt, tell you can ask. No? You get the idea? How will I solve this? Because basically, in this question, they're asking which is a better gas welder. So for better gas welder, better gas welder means what? Better gas welder means those having the high calorific value, CV value. CV value actually represent the how good the CV value actually represent how good our fuel is, right? Our fuel or food, how good it. If the fuel is good, then it having a high calorific value. Now, the next is enthalpy of neutralization. So what do you mean by this term enthalpy of neutralization, right? So basically the enthalpy change when the one equivalent of an acid is neutralized by one equivalent of base in fairly dilute solution is called heat or enthalpy of neutralization. So always remember this, whenever the enthalpy change when the one equivalent of an acid is neutralized by an equivalent of a base in a fairly dilute solution is called heat or enthalpy of the neutralization. It is denoted by delta NH, right? When the HCl is treated with NaOH, it will produce NaCl plus water. So whenever the acid and base are treated, they are the example of neutron reaction and the water formation takes place. Here, the heat release is called minus 13.7 kilocalorie. So this much of heat is released. Now, the heat neutralization of the strong acid against the strong base is always constant. So always remember this, the heat neutralization of a strong acid with a strong base is always constant. It is equal to 13.7. Just remember this. Kilocalorie equivalent or 57.1 kilojoule. Right? This is because the heat formation of water in case of dilute solution is this. Now, for the weak acid against the strong base, or a strong acid against the weak base, or a weak acid against the weak base, its numerical value is always less than 13.7 kilocalorie. This is because here some of heat is used up in the ionization of acid or base. However, for the HF, delta H is higher due to the high heat of hydration of fluoride ion. right? So this is the important fact about the enthalpy of neutralization that we must keep in our mind. Now, again, neutralization reaction are always exothermic. So this one is also very important. That is neutralization reaction are always exothermic. The second name, thus, it is always have a negative value, right? The heat of neutralization of an acid or base can be easily determined in the laboratory with the help of the polyethane or polystyrene. Right. So how we'll calculate basically beta, how the calculation of enthalpy of neutralization. Basically to calculate the enthalpy of neutralization Q, we know the formula like enthalpy of neutralization is equal to Q upon 100 into 1000 into 1 by X, right? Where T1 and T2 are the initial and the final temperature, right? And Q is the heat change in the reaction and X is the normality of acid or base. So this is how we can actually calculate. Now, in the next question, they are asking when the 50 ml, right? So in this question, they are asking when the 50 ml of 1 molar HCl with the 50 ml of 1 molar of NaCl, the enthalpy of neutralization. So no need to solve. We already know that in case of a strong acid or strong base, the enthalpy of neutralization is always minus 57.1. Okay, this is always minus 57.1. So no need to calculate this. It comes out to be this. Now there is one exception in this that how will you when you going to solve this? We know this in case of 50 ml. So they are asking about the 50 ml, right? So when the 1 mole of neutralized by the 1 mole of NaOH, the enthalpy of neutralization is 0.57 kg. It is very much clear. Now in this, they are asking about the 0.05 mole of HCl neutralized. So if the 1 mole, just remember this formula. If the, let me write the equation first. This is HCl, right? So this is nothing but NaCl plus H2O. So can you calculate the molar concentration of this? How will you calculate beta? Yes, we have because 50 ml. Right. So this is 15 ml. 1 molar solution means what? 1 liter. So they having 1 liter. So this is 1000. So they having concentration 0.05 mole per liter. Right. 0.05 mole per liter. Here also we can calculate NaOH as well. This is also very much similar. So this will also comes out to be 0.05 mole. Right? This will also comes out to be 0.05 mole. Okay. So if let us assume this, if 1 mole of HCl is neutralized by the 1 mole of NaOH, then the 0.05 mole is neutralized by 0.0 mole of NaOH. So what is the enthalpy of reaction? So enthalpy of reaction is nothing but minus 57.1, right, into 57.1 into the value 0.05. So you'll get this, you'll get 2.9 kilojoule, right? So this is the correct answer. I hope you understand this thing. Is there any problem in this question? Any problem? No? Right. Okay. So this is how we can actually solve this. That is delta enthalpy of reaction is comes out to be 2.9 kilojoule. Let's see the next one. The enthalpy change when the 1 mole of the solid is dissolved completely in the axis of solvent, right, is called enthalpy, or we say heat of the solution. The solvent used here is usually water, right? So it is basically water. So basically the enthalpy change when the 1 mole of solute is dissolved completely in the axis of solvent is called enthalpy, or we say heat of the solution. The solution used here is usually water and it is denoted by delta of solution H. An example, like when the ammonium chloride is treated with H2O, then form ammonium chloride aqueous, right? So here the enthalpy of solution comes out to be 3.90, right? So enthalpy of solution we can also calculate by subtracting the value of hydration energy minus mean lattice energy. So if you know the value of hydration energy and lattice energy, then we can subtract this value to get this. I hope this is clear to you, right? Okay, so this is how you can calculate this. Now, I'll move to the next thing, that is enthalpy of hydration. Okay, so basically what is the enthalpy of hydration is the enthalpy change or the heat of the hydration when the 1 mole of substance combined with the required number of moles of water to form a specific hydrate. Its symbol is this. This is known as enthalpy of hydration, right? It is very simple to understand. Similar enthalpy of atomization when the enthalpy change that accompany the total separation of all the constituent atoms in a chemical substance, either element form or a molecule or a compound is called enthalpy of atomization. Now, this one is going to be very important. So I quickly, revise this thing. What is bond energy and bond dissociation energy? Basically, when the bond is formed between the two atoms in a gaseous state to form a molecule, some heat is always emitted, which is called bond energy, or we say bond formation energy, right? So you must remember this thing. Now, uh, bond dissociation energy is the amount of energy required to break or dissociate the bond of the particular type, right? So this is the bond dissociation energy. That is the amount of energy we must require to break the or dissociate the bond of the particular type. Okay, that is between the same two types of atom present in the one molecule or maybe the different. Now, the bond energy is taken as the average value of the dissociation energy of the same type of bond present in a one mole. In case of diatomic molecule, bond energy is equal to the enthalpy of bond dissociation, right? Like HCl, the HCl dissociate to give H plus and Cl. So here the delta H is nothing but is equal to 431 kilojoule per mole. Similar, however, in case of polyatomic molecule like CH4, so when they dissociate into C and 4H, their enthalpy is 6064. Now CH bond energy is equal to half 1 by 4th of the bond dissociation energy. We know that total we have a 4 bond, so just divide 1664 with 4. So you'll get the 416 kilojoule per mole, right? So as the chemical reaction is involved in the breaking of the old bond in the reactant and formation of the new bond in the product, the enthalpy change of the reaction can also be calculated by the following formula, like sum of the binding energy of the reactant minus sum of the binding energy of the product. Now, what are the various factors which affect the bond energy? So the various factors which affecting the bond energy are: the first one is size of an atom. Smaller the size of the atom, higher will be the bond energy, and vice versa. Similar electron activity. The bond formed between the atom having the large difference in their electron activity values are more polar and more ionic. Hence, their bond energy will be larger. Third one is bond length. That is, shorter the bond length, higher is the bond energy. Right. So these all are the factors affecting the bond energy. Right. Next, the bond energy order of the different types of bonds will be like triple bond having most with second bond with double bond and like this. Okay. Now, question 13. This one is very, very important, right? So this is also a very important question. So in this question, what they ask basically, so bond energy of HH bond is given, that is 430 kilojoule per mole. And that of CCl bond is also given 242 kilojoule per mole. Now, if the heat of the formation of HCl is 91.91 kilojoule per mole, then the bond energy of the HCl will be. Will you try to solve this? This is very simple question, just related to the previous one, right? Let me show you. Okay, so we know that in this reaction, H2 plus Cl2, this will gives us 2 HCl. And here delta H of formation is given minus 91.1 kilojoule per. ठीक है. So delta H of formation is nothing but 91.1 kilojoule per mole. Now in this reaction, 2 mole of HCl are produced, right? So the 2 mole of HCl are produced. So in this, the enthalpy of reaction, product side, what is delta RH is nothing but is equal to 2 into delta H of formation, or we say forward into H. So it will equal to 2 into minus 91, which is equal to minus 182 kilojoule per mole, right? So it is equal to 182 kilojoule per mole. Now let the bond energy of HCl bond is X. So let the bond energy of bond now. So let the bond energy of HCl bond is X, right? So just assume this. That is the bond energy of HCl bond is nothing but it is equal to X. So similar the two for the 2 mole of HCl, the it will become 2X, right? It will become 2X. Okay. So now let me write here. So we can from the equation we can observe HH plus ClCl. This will give 2HCl, right? So just put the value what we have so far calculated. So we know that delta H of reaction, enthalpy of reaction is nothing but what? That is the binding energy of the product minus binding energy of reactant. Right? Binding energy of the product minus the binding energy of the reactant. Now, what is the binding energy of this here is given. So you already know that for this one, it is already given minus 182 and this is 430 plus 242 minus 2x. So what's the value of x here? X comes out to be 854 upon 2, or we say 427 kilojoule per, right? So 427. The option A is absolutely correct. Okay. So this one is also very important. That is the Hess law. So just read this 1 minute. I'll give you 1 minute. Just read this till I take some water. So just try to read this and no understand what do you mean by the Hess law. I explain you in this 2 minutes, right? So what is Hess law basically? Just read the definition. Yes. What is Hess law of constant heat summation beta? Can anyone? Like, how will you define this? Basically, the total heat change accompanying a chemical reaction is the same, whether the reaction takes place in one or more steps, right? All enthalpy change in a particular reaction is always constant and is independent of the path in which the reaction takes place, right? So this is always equal to, always same, whether the reaction takes place in one step or multiple steps, right? I hope you understand this thing. What is Hess law of constant heat summation? Okay, basically, whether the reaction will take place in a one step or in a multiple step, but the value of the heat always remain the same. Okay, so this statement, the best statement is called the Hess law of constant heat summation. So let's see this let's see this with an example uh, we have a two option. Either we'll go from A to B directly, or we go A to B with the first you have to, I have to go from A to C, and then from C to D, then after from D to B. So we have a three option. Either we'll go directly from A to B, or we go through C and D to B, right? So according to the Hess law, delta H, whether the reaction takes place in one step, or we delta H1, delta H2, and delta H3, they all remain same. Whether delta H is equal to delta H1 plus delta H2 plus delta H3, right? It means Enthalpy change delta H according to the Hess law is equal to this. Delta H1 plus 2 plus 3, right? Here H1, H2 are the mainly enthalpy change when the B is prepared from A through an intermediate C and D. When a compound show resonance, there is a considerable, difference between the heat of formation as calculated from bond energy and that determined experiment. Like resonance energy is nothing but is equal to experimental or the actual heat of formation minus calculated heat of formation. So what is thermochemical equation basically is, right? What is thermochemical equation? So thermochemical equation basically the following points are kept in mind while writing the required thermochemical equation. The first is if the heat of formation of methane is to be determined, write down the following equation. So first of all, you should write the chemical equation which must be balanced. So this is the first criteria for writing the thermochemical equation. So try to obtain the required equation from the given data. There are the two ways by doing this. First way by adding, subtracting, and multiplying various the thermochemical equation, or second way by enthalpy of reaction by just enthalpy of product minus enthalpy of the reactant. So that also you can get it. Now, this question you have to calculate the standard enthalpy formation of methanol. So we know that how will you prepare methanol? So what is the aim here? Again, here aim is our C plus, right? So this is C, and we want 2H2, right? Plus half O2, half O2. So this will gives us methanol, CH3 and OH, right? So this will gives us methanol. So this will gives us methanol, CH3 and OH. So this is what we get. Now, next thing, when the C plus 2H2 combined with half O2 will give methanol, CH3OH. Now, next thing is what? Next thing is nothing, but this is our aim. So, how will you fulfill this aim using this, three equation? So, the main thing through which we obtained this is like from equation number two, right? Let me write the name of the equation. This is equation number one. This is equation number two, and this is equation number three, right? So this is equation number one, two, and three. Okay. So from equation two, we get the value of C. From equation three, we get the value of H2, just multiplying by two, this equation, right? And oh, sorry. Okay. And methanol is for this left hand side. So just subtract this equation. So what is the required step for this? Required step is nothing but add equation 2 plus 2 into equation 3, right? So add equation 2 plus 2 into equation 3 and subtract. What you have to subtract? And subtract equation 1. Now, by doing this, you'll get the desired equation. How will you get this? Let me show. Right. So, what is equation? Add equation two. So, add equation two is nothing but C plus O2. So, this will become C plus O2. Right. C plus O2. So, equation adding with equation three, that is 2H2 plus O2. So, this will become 2H2 plus O2. Right. And subtract equation 1, that is CH3OH minus CH3OH minus 3 by 2 O2, 3 by 2 O2, right? Now move to the right hand side. Right hand side we have a CO2 plus 2H2O, CO2 plus 2H2O, and subtract this with the CO2 plus 2H2O, right? CO2 plus 2H2O, that is CO2 minus 2H2O. As we can observe here, this O2 get cancelled. No, this O2 and this O2, right? So this will become C. This will become 2H2, and this O2 become 2O2, right? 2O2 minus 3 by 2O2 minus CH3OH, and this will cancel out, right? This will become 0. So here we'll get C plus 2H2, and we know that 2O2 minus 3 by 2O2 is equal to half O2. So this will become half O2, and this CH3OH, if it will come this side, it will become positive. So this is what you'll get. This is the required equation only, na? This is only we want to prepare. So yes, it is confirmed that. So just put the value of enthalpy according to this. That is the enthalpy of equation 2, which is nothing but minus 393 kilojoule plus 2 into minus 286. That is the enthalpy of equation third minus that is minus 726. So if you do this, right? So if you do this, you get the value. So I hope this is very simple. Any doubt, beta, related to this? If you have any doubt, you can ask. Anyone? No? So the correct answer is minus 230. Right. So 239 kilojoule per mole is the correct answer. So any thermochemical equation, if they come, you have to solve the thermochemical equation like this one. Right. So basically, what is heat capacity? So heat capacity is the quantity of heat required to raise the temperature of the system by 1 degree. Is called heat capacity. It is denoted by C, and heat capacity is a path function. So how will you derive the formula? Heat capacity is equal to dq over dt. Now, the magnitude of heat capacity depends upon the size, composition, and the nature of the system. Heat capacity varies directly with the amount of substance. It also affects the temperature. If the magnitude of the heat capacity is large, there is only a small rise in the temperature by a given amount of heat. That is, the heat capacity of H2O is large, thus the large amount of heat is required to raise the temperature. Now, what is specific heat capacity? What is this specific heat capacity? Basically, in a chemical calculation, we often use specific heat capacity and molar heat capacity. Specific heat is defined as the heat required to raise the temperature of 1 unit mass by 1 degree. And molar heat capacity means amount of heat required to raise the temperature of 1 mole of substance, right? So this is the formula for finding the molar heat capacity, that is Q is equal to nothing but C into M into delta T. So basically heat capacity at constant volume is also known as Cv, that is equal to du by dt at constant volume, and this will known as enthalpy, that is dH by dt. So just putting these two values, we get the relation like Cp minus Cv is equal to R. So this relation is very important. Just learn this relation Cp minus Cv is equal to R. Right? So now let's see some numerical, right? That is a previous year question that were asked from this topic only, right? So let's see the some previous year numerical so that you can understand this concept in a better way, right? So let me show you. Yeah. So this is the advanced question, previous year advanced question that were asked in a previous year examination. So what the question is basically, so let's understood and solve the question each by each, right? So the first question, in the first question they asking, 1 mole of an ideal gas at 300 Kelvin in a thermal contact with the surrounding expand isothermally from 1 liter to 2 liter against a constant external pressure of 3 atm. In this process, the change in entropy of the surrounding is. So you have to calculate the change in the entropy for the case of reversible isothermal process, right? So you have to calculate for this. Now, we know that what is the formula for entropy? It is very basic. That is, we can calculate entropy by using the formula like just dq over t, right? So if you know this dq over t, q and temperature, then we are able to calculate the what? Then we're able to calculate the entropy. Okay. So how will you calculate dq and t beta? Can anyone tell me how to calculate dq here? Okay. So first, this is a isothermally process, right? Expand isothermally against the constant external process. Okay. So if this process is isothermal, it means what does it mean? Isothermal means what? Isothermal means isothermal means temperature is constant. So if the temperature is constant, then delta U, that is internal energy, is also zero. because internal energy is the function of temperature only. So if the temperature is constant, then delta U is also 0. Now, we know that delta U is equal to Q plus W. Okay. So if delta U is equal to 0, right? Delta U is equal to 0. Then Q is equal to minus W, or we say W is equal to minus Q. We can write anything, right? W is equal to minus Q. How will you calculate the work done in case of constant pressure? We know that it is nothing but it is equal to P external, minus, and this will be V2 minus V1. This is how we can calculate the work done, right? This is the formula for work done, na? Minus P into delta V. So just put the value. P external, so P is constant and it is equal to 3 atm. So this is equal to 3 into, just convert this 0.1.3, right? So this is just put the value. There is no need to convert. Just put the value of P like 3 atm. What is delta V here? Where 2, 1. So 2 minus 1. It comes out to be 3. Right. So it comes out to be 3, and this is atm liter. We know that how to convert atm liter into joule. So 1 atm liter is nothing but 1.01 joule. Let me write 101.3 joule. So this is the work done. So if you know the work done, then the value of Q is nothing but negative of this. Just put the value in this, right? So what the delta is? Delta S is equal to dq. What is dq here? Dq is nothing but minus 3 into 101.3 divided by 300. So on solving, you'll get like 1.013. So this is the correct answer. That is 1.013. Okay, and the value is in negative or positive? The value is in negative. So this one. Okay, the value is in negative. That is minus 1.013. So this is the first question, and it is good question. I don't say it is a very difficult or very easy question. So it is a moderate level of question. If you know the concept behind this, if you know how what is isothermal process, what is the internal energy, then you know this easily calculate. Now, the second question is, in the second question they are asking, tin is obtained from the cassiter by the reduction with the coke using the data given below to determine the minimum temperature in Kelvin at which the reduction of a cassiterate by coke would take place. So at 298 Kelvin, SNO2S give us this, and delta is given, right? Delta G is given for this reaction. Okay. So assuming that the enthalpy and the entropy are temperature independent. So you have to calculate for this, right? So how will you calculate this beta? We know that one very simple equation that is here. In this question, it is already given SNO2, this react with carbon to give CO2 plus Sn, right? CO2 plus Sn. Now here delta H is nothing but delta F formation of product minus delta formation of enthalpy reactant, right? So the formation of the enthalpy of product is already given. It is equal to nothing but 394. And this is also given, that is 581. 581, right? This is also given at 581. So what the values comes out to be 187. 187 kilojoule per mole, right? So just assume this, that is the 2 at 298 Kelvin. OSNOT, that is give 581. This is already given, this one, right? This one and this one. So subtracting, we get 187. Okay, no issue. Similar for the enthalpy as well. This is for enthalpy. Similar for entropy. So we get entropy is already given, that is 210 plus 52 minus 56, right? So 210 minus 52 plus 56. Okay. So 210 plus 52 minus 56. What you get, beta? Minus 6, 56 minus 6 also. So we'll get like 200 joule per Kelvin. So what is delta G? We know that this and this. So delta G is equal to delta H minus T into delta S. This is the formula we know. So delta H is nothing but 187, and for joule we convert this into 1000. Minus what is T here? T is nothing but 200, right? T is nothing but 200. So this will be 200 into T. Just value, put the value of T, or you have to calculate the T. So here the delta G is already given, right? So how will you calculate this? Temperature in Kelvin you have to require now. So just put the value of delta G here. So what is delta G? So delta G is already given. That is delta G is nothing but this is equal to 187 into 1000 minus 200 into T. So T is equal to 187 into 1000 divided by 200, right? So from here it calculate T comes out to be 935 Kelvin. Okay, so this is for the equilibrium. Okay, this is at the point of equilibrium. So we can calculate this. So first we calculated delta H, then we calculated delta S, then we use the formula delta G is equal to H minus T delta S, and after this we'll get this. Okay, now the third question is, it is also very important one, right? So what the question asks basically, in the thermodynamic PV work that is given by minus dPV, right? P external, this one is correct. For a system undergoing a particular process, the work done is dV by dt upon V minus B into A minus B square. The equation applicable to a system that satisfies the van der Waals equation of the state. So this is absolutely correct, because we know that work done is equal to P external into dV, right? Now from the van der Waals gas equation, we know that what is van der Waals gas equation? Van der Waals gas equation is nothing but P plus A upon V square, right? V minus B. This one is equal to RT, is equal to RT. So P plus A upon V square, V minus B is equal to RT. Or we say from here, we can calculate P as well. So P is nothing, but it is equal to RT, right? RT upon V minus B minus A upon V square. So this is how we can calculate P. So if you put the value of P in this, right, for the irreversible process, P external is equal to P gas. So process is not applicable only for the irreversible process. Hence the correct option is A. That is option A is correct. Reversible is correct. The process is reversible and adiabatic. So this process is not the irreversible. So the correct option is, that is A, B, and C. Now move to the next question. That is, in this question, a reversible cyclic process for an ideal gas is shown below. Here PV and T are the pressure, volume, and the temperature respectively. The thermodynamic parameter Q, W, H, and U, and the heat work enthalpy internal energy respectively, right? So you have to identify the correct option. So as we can say that from A to C, the process is A to C. This is volume, right? This is volume, this is temperature. So in this, you have volume. So from A to C, that this is isocoric process. Isocoric, right? So A to C is isocoric. Similar from A to B, temperature constant, it means it is an isothermal. So this one is an isothermal process. So EC is isocoric because volume is constant. Similar, A to B is isothermal. So isocoric, isothermal. Again, BC, isobaric, right? So BC is isobaric. Now, QAC is equal to delta UBC, which is equal to NCB T2 minus T. Can you get the, how will it obtain? Because from during A to C isocoric, we know that during isocoric work done is equal to 0. So delta U is equal to nothing but Q plus work done. Na? So the work done is equal to 0, then delta U is equal to Q. So this is what you get, right? So this one is correct. Now the second one is work done from A to B is equal to nRT1 ln V2 upon V1. Now, Q from BC is equal to delta H of AC, which is equal to NCP T2 minus T1. Now, heat from B to C. So, B to C is an isothermal process. So, during isothermal process, delta U is 0. So, if the delta U is 0, then Q is equal to W. And the heat supply at a constant is known as enthalpy, right? So, which of the following is correct? So, the correct option are only B and C. That is B and C. So, only B and C are the correct option, and rest all are incorrect. Okay. Now, read this question. Okay. So, an ideal gas is expanded, right? So, an ideal gas is expanded from P1, V1, T1 to P2, V2, T2 under a different condition. The correct statement among the following, right? So, let's see. If they are expanded, where the condition is like P1, V1, and T1, they are the condition like P2, V2, and T2, right? Okay. The work done on the gas is maximum when it's compressed irreversibly from P2 V2 to P1 V1. कह रहा वर्क डन इज मैक्सिमम होगा जब इसको हम P2 से V2 से P1 V1 ले जाएं अगेंस्ट द कांस्टेंट प्रेशर P1. Right? Is it true? Yes, this is true. Obvious. Next is the work done by the gas is less when it expanded reversibly from V1 to V1 under the adiabatic condition as compared to that when expanded reversibly from V1 to V1 under the isothermal condition. This is also correct. If the expansion is carried out in a freely, it's simultaneously both isothermal as well as adiabatic. Now, the change in the internal energy of the gas is zero if it expanded reversibly with T1 is equal to T2. And positive is expanded reversibly under the adiabatic condition T1 is not equal to T2. Right? So, obvious work done is negative when the work is done on the system. Work done is positive for the adiabatic work and work done is positive for the isothermal reversible work done by the gas. Now, let's see the C point, whether C is correct or not. So, as the free expansion in there, then P external is 0. For the free expansion, P external is 0. So, if the P external is 0, it means work done is also 0. Work done is also 0. So, isothermal reversible process, delta U become negative. Right, delta U become negative. Why? Because delta U is equal to nothing but Q plus W. If this Q is delta U is equal to 0 for isothermal, then this Q is equal to minus of W. Right. So this will become negative. The work done is become negative. Right. So from this we can say that for this question only option A, B, and C. That is A, B, and C are correct, not the D. Now this is question number 6. What the question basically asks. An ideal gas is in a thermally insulated vessel at an internal pressure P1 and volume V1 and absolute temperature T1 expand reversibly against the zero external pressure as shown in the figure. The final internal pressure, volume, and absolute temperature of the gas are P2, V2, T2 respectively. For this expression, you have to calculate the following data. Since the container is thermally insulated, what does it mean? It means Q is equal to 0 and is in case of free expansion, therefore the work done is also equal to 0. So these two points we get from the question. That is Q is equal to 0 because they are thermally insulated and W is equal to 0 because free expansion is there. So, what is actually here is if Q is 0, W 0, then delta U is also equal to 0, right? Then the internal energy is also equal to 0. If internal energy is 0, what does it mean? It means it is a constant, that is the temperature is constant because at constant temperature, internal energy is 0. So, T1 is equal to T2. Now, when the T1 is equal to T2, also when the temperature is constant, we know that P1 V1 is equal to P2 V2. We know this thing. P1 V1 is equal to P2 V2. So P1 V1 is equal to P2 V2. That is which option? That is option number C and option number A and option number B. So these all are the correct one, right? So which option is correct for this question, beta? So the solution, correct option is the volume. So in this question, what they ask you, the final internal pressure, volume, and absolute temperature of the gas are P2, V2 for this expansion, right? So you have to, for this expansion, P2, V2 is equal to P1, P1, right? So that we can derive this. Okay. So this is the desired equation. Now, let's move to the next question. What the question asks basically. So this is a paragraph type of question, right? So in this question, they're asking the succeeding operation that enable the transformation state are heating and cooling, right? So as we can observe from, right? So basically in this question, what they ask now, a fixed mass of m of gas is subjected to a transformation of the state from K to L to M and back to K. So K to L and L to M, K to L, M to K, right? M to K again they write. The succeeding operation that enable the transformation. So what is this? This is nothing but is equal to C, right? So how the process takes place better? Let me explain you. From K to L, K to L, this is at constant pressure. At constant pressure. So at constant pressure, volume increase. Thus we get heating effect. Heating. Now from L to M at constant volume, pressure decrease and thus cooling. Cooling. Now from M to N, right? From M to N at a constant pressure, again decreases, volume decreases, then cooling. Again from N to K at constant volume, pressure increases, thus heating. So what we get, that is cooling, heating, cooling, heating. So the correct option is, which one is the correct one beta for this? That is C. That is heating, फिर cooling, फिर heating. So this is heating, cooling, and then heating. Right? So option C is. This is also a similar question. Like this is the part of this question alone. So in this question, they are asking the pair of isochoric process about the transformation of state is. So you have to identify the isochoric process. So we know that from K to L, it is isobaric. K to L, it is isobaric. Similar from L to M, this will be isochoric. And from M to N, again isobaric. N से K, isochoric. Right. So from K to L, we have this K to L and N to K. So K to L and N to K. So K to L and N to K is the correct one. So the correct option is B. Right? L to M and N to K. During this process, we'll get this one, that is the isothermal part. Okay. So we cover almost different types of PYQ that generally asked from this chapter. So try to understand this thing as well, right? That is which type of they are generally asking from you. Now let me show one important thing to you. Right? So remember this, basically entropy. What is entropy is this, right? So basically entropy is nothing but the property of the system which measure as the degree of randomness, right? So it is a state function and change in entropy will obtain like this. If I'm talking about the solid, liquid and gas having the highest entropy because in gas having the maximum randomness. So those having the maximum randomness having the maximum entropy as compared to the other one. Okay. Now, some example in which the entropy either increases or decreases if the molecule is kept in a larger volume. Container will have a higher entropy. Similar decomposition of the compound increase the entropy will also increase, right? In case of atom molecules belonging to the different elements, the one with the higher mass have a greater entropy, or for inert gases, we can say this, right? Now, there's the one important formula that you must be remember, like let me discuss. Yeah, that is delta S total, that is the entropy of the system plus surrounding is positive and the process is spontaneous. Now, if the entropy, total entropy or the universe of the entropy is negative, then the process is non-spontaneous. You must remember this. If delta S of total universe is zero, then the process is in equilibrium. So this is delta F, which is equal to Q over T. Delta S of surrounding is equal to minus Q upon T. And this is how will you calculate this, right? For the spontaneity and the non-spontaneity. Yeah, this is also you can remember that is the entropy change for the ideal gas. In case of isothermal process, the formula is delta S is equal to Nr ln V2 by V1. And in case of this, we'll get Nr ln P1 by, right? So for the isobaric process, we also have a NCP, and that is ln T2 over T1. And similar for the isobaric process, we have a delta S is equal to NCV T2 minus T1, where the volume is constant. I hope you understand this thing. Okay. Similar, the one more important note here is uh, you can understand the second law. That is basically it is it gives the spontaneity. Whenever the process spontaneous takes place, always accompanied by the increase in the total entropy of the universe. That is, the entropy of the universe is always system plus surrounding. Or we say there's a two statement. The first statement is impossible to take heat from the hotter reservoir to completely convert into the work. And the second one is it is impossible for the cyclic process to transfer heat from a body at a lower temperature to one at a higher temperature without converting some work to heat. This statement of the second law of thermodynamics known as Clausius statement. This is the third law of thermodynamics, that is according to this law, the entropy of the perfectly crystalline substance approaches zero as the absolutely zero of the temperature is approached, or we say it forms the basis from which the entropy at the other temperature can be measured. Okay, so this is all about we need to know. This is the Gibbs energy. If the Gibbs energy is negative, then the process is spontaneous. If the Gibbs energy is positive, then the process is non-spontaneous. And if the delta G is zero, then the process is an equilibrium state. Right. So this is all about. So today we'll cover all this thing. Right. So now from the tomorrow onwards, we're going to start our new chapter. So just try to solve the numericals. Just try to solve the entire question. What we discussed so far. Okay. So let's meet in the next class where we'll discuss all this thing.